Example 2. You're pretty sure that your candidate for class president has about 55% of the votes in the entire school, but you're worried that only 40% of the students will show up to vote. People are lazy, not everyone's going to come and vote. We want to create and describe a simulation to determine if your candidate, determine if your candidate will win the election. Now, on the last example, we used the numbers or one-digit numbers from 0 to 9. We had 10 total. Now this time, we think that our person has 55% of the votes. If I write out my digits here from 0 to 9, there's no way that I can allot 55% of this. It's an even number, it's just 10. I can get 50%, I can get 60% if I went all the way, 60 would be here, but there's no way I can get 55. So that means that these single digit numbers won't work. So instead, we'll try two-digit numbers. Now the smallest two-digit number is 0, 0. The next would be 0, 1, 0, 2, 0, 3, and I would continue. I'd hit the 10s, 20s, 30s, 40s, 50s, 60s, 70s, 80s, and the largest two-digit number I would have is 99. Now I want to separate these to give me 55%. I don't expect you to sit here and write out all 100 of your two-digit numbers. We're going to have 100 values here, 100 numbers, starting at 0, 0, going all the way to 99. If I want 55, I usually start at 0, 0. I go one less, 54, 55, 56, and I know this thing's going to end at 99. Now I want 55% of the vote, so 55 digits. 0, 0 counts as a digit, that's my first option, so I actually want to stop at 54. If I stop one less than 55, because of that 0, 0, this will give me 55 values, which is equal to 55%. The 54 to 99 will give me the other 45%. So just like we saw in the last example, I'm going to start with talking about what these digits represent. So let 0, 0 through 54 represent a vote for my candidate. And 55 through 99 represent a vote, I'm just going to say, against my candidate. Not sure if there are two people running or more than that, but I am just going to say for and against. Now the next thing I need to do is talk about what I'm going to do in this random number chart. So I'm going to say I'll go through the random numbers and this time I'm going to switch things up. I'm going to highlight votes for my candidate and leave votes against blank. So yours might be different. You could say that you are going to circle votes for or underline votes for, but I'm going to go ahead and highlight votes that are for my candidate. Now I don't want to sit here and do this forever, so I need to talk about when I'm going to stop. I think that only 40 students are going to show up and vote, so I'm going to continue this process until I reach a total of 40 votes. So I'll stop once I reach a total of 40 Now, when we go to that random number chart here, remember that we are looking for 2-digit numbers. So the first one I see is 73. 73 is a vote against. So I'm not going to mark it. Sometimes it helps if you put kind of a slash there in between. So the next number again is 73. That's a vote against. Next up, I have 54. 54 is a vote for my person. There's our first vote. So we've got one. Next up is 59. That's a vote against me. 63, vote against. Things are not looking great. 78, that's a vote against. 13, that's a vote for. 46 is my next one. I know there's a blank there, but we're still just looking for 2 digits. That is a vote for. 38 is my next one. That is a vote for. And 73, that is a vote against. Now I like to stop and just count how many votes I have right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 votes. I need a total of 40. So I'm going to have to go through 4 rows. Okay, 02, that's a vote for. 96 is a vote against. 55 is a vote against. 83 is against. 03 is for me. 90 is against. 70 is against. 82 is against. This one's kind of funny. 00, that is for. And 25 is for. 98, no. 85, no. 92, no. 38 is a yes. And 51 is a yes. 27 is a yes. 96 is a no. 56 is a no. 23 is a no. 90 is a yes. Sorry, 23 is a yes. 94 is a no. Right now I'm at 30. These are 10 each. So I need 10 more votes. Okay, so 33, that's a yes. 66 is a no. 66 again is a no. 25 is a yes. 70, that's a no. 64 is a no. 77 is a no. 57 is a no. 84 is a no. Whew, we ended on a good note. There is 28. Again, we're going to write our final sentence here, a little bit of a conclusion. So I'm going to say, based on my simulation, my candidate will get, let's see how many votes they get. I'm going to count this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 votes out of 40. So they would lose the election. Now, does this mean that my candidate is definitely 100% going to lose the election? No, this is just a simulation. This is just one possible outcome of the scenario. Example 3 says 57 students participated in a lottery for a particularly desirable dorm room. It's a triple with a fireplace and a private bathroom. It's a hot commodity. You definitely want that triple. 20 of the participants were members of the same varsity team. We want to find what are the chances that all 3 participants chosen are from the team. And they want us to perform 5 trials. Now, what's different about this one is they don't tell you the percentage. We have to calculate that percent ourselves. Now, we're looking for participants that are all coming from the same team, and they told us that 20 of the participants were from the team. out of, it looks like 57 students participated in total. So I'm going to type in my calculator real quick. 20 divided by 57, and I got about 35%. 35 is another one where I'm going to have to use 2 digits. So if I'm starting at 0, 0, zero, zero counts as 1. So again, I'm going to stop 1 less than the percent I'm looking for. This we will represent people on the team. All these other values are not on the team. Okay, so I'm going to say let 0, 0 through 34 represent people on the team. And 35 through 99 represent people not on the team. Okay, we will go through the random numbers. And this time I'm going to box up the people on the team. Box team members. And let's circle non-team members. Okay, I don't want to do this forever. In this case, we're looking for people that are being assigned to a triple. Triple meaning there's 3 people in a room. So I will stop once I have 3 people selected. They do want me to repeat this a few times. I want a total of 5 trials, so I like to just include in here, I'll repeat for 5 trials. Alright, so I'm going to start my first trial on this first row. So I'm just going to label this as trial 1. And I'm looking for double digit numbers here. So first one I see is 1, 1. That is a person on the team. 1, 6 is my next one. That is another person on the team. And 4, 3 is somebody not on the team. Okay, for trial 1, I'm going to stop there because that's 3 people and that has 2 team members. So I'm just going to off to the side here, maybe right here, 2 team members. Okay, we'll continue. Trial 2, I'm going to start this at a new line. 21 is my first one. That is somebody on the team. 21 again, team member. 59, not a team member. Again, 2 people from the team. Trial 3. 10 is a team member. 43 is not. And 84 is not. So that one had 1 team member. Trial 4. 36, not a team member. 79, not a team member. 22 is a team member. So there's 1. Trial 5, my last trial here. 73, not a team member. 94 is not a team member. And 40 is not a team member. So this one has 0 people from that team. Okay, I'm going to kind of conclude here. So based on my simulation, I'm going to say of 5 trials, And I was looking for the chances that all 3 participants were from the team. That did not happen at all. So I'm going to say, based on my simulation, none of the trials ended with all participants being team members.